So, good morning, students. Today we'll continue again with unit number 4 and topic number 2, which is seepage losses and channel losses and design of lined and rigid boundary canal using Manning's equation. So, in continuation with our previous topic, the second one was for canal losses, the second one was absorption. So, in absorption, a small saturated soil zone exists around the canal section and is surrounded by zone of decreasing saturation. A certain zone just above the water table is saturated by capillarity. Thus, there exists an unsaturated soil zone between the two saturated zones as shown in figure 3.8. So, in this case, the rate of loss is independent of seepage head, capital H, but depends only upon the water head, small h, that is, distance between water surface level of canal and the bottom of the saturated zone, plus the capillary head H suffix C as shown in figure 3.8. The seepage losses depends upon the following factors. The first one is type of seepage, that is whether percolation or absorption, which we have already studied. Second is soil permeability. Number 3, the condition of the canal. The seepage through a silted canal is less than that from a new canal. Number 4, amount of silt carried by the canal. The more the silt, lesser are the losses. Number 5, velocity of canal water. The more the velocity, the lesser will be the losses. Number 6, cross section of the canal and its wetted perimeter. For designs, a combined figure for seepage losses as well as for evaporation losses expressed as cubic per million square meter wetted perimeter may be taken as tabulated below. So, here the type of soil through which channel is excavated or dug out and total loss in cubic per million square meter of wetted area. The first one is rocks. Total loss is 0.9, black cotton soil 1.6, alluvial red soil 2.5, decayed rock or gravel etc. 3.0 and loose sandy soil 5.5. Empirical formula for channel losses. The channel losses can be determined by using certain empirical formulas given below. Delta Q, which is equal to channel losses in cubics per kilometer length of channel, is equal to 1 by 200 B plus D to the power 2 by 3. B is the bed width of the channel in meters and D is the depth of water in the channel in meters. This formula is generally used in Uttar Pradesh. So next is delta Q, which is losses in cubics per million square meter wetted perimeter, is equal to 1.9 capital Q to the power 1 by 6. Here Q is discharge in cubics. The above formula is commonly used in Punjab. Next, design of lined and rigid boundary canal, Manning's equation. In rigid boundary channels, the surface of the channel is lined. We have already studied about lined canal and unlined canals in our previous classes. If you have forgotten it, then you can go back and see after this lecture. The quantity of silt transported by such channels remains more or less the same as that has entered the channel at the head. In such channels, relatively high velocity of flow is usually permitted, which does not allow the silt to get deposited. Therefore, for these channels, the problem of silt usually does not exist. If the bed and sides are scored, the cross-section increases and the full supply level falls, which results in a decrease of common. On the other hand, if so silting occurs, the cross-section decreases and the discharge capacity decreases, which also results in a decrease of common. Such channels should be designed for a non-scoring and non-silting velocity called critical velocity. A line canal is a rigid boundary channel. It can withstand much higher velocity as compared to an unlined non-alluvial channel or alluvial channel. The design is similar to the design of non-alluvial channels discussed in the preceding section. However, the maximum permissible velocity is relatively high. Here in this table, you can see the types of lining and the maximum permissible velocity in meter per second for each type of lining. First one is boulder lining. The maximum permissible velocity is 1.8. Brick tile lining 1.8. And cement concrete lining 227. Sorry, for boulder lining it is 1.5 and not 1.8. Next, the design of line canal is usually done by Manning's formula. The value of Manning's coefficient small n depends upon the type of lining. The higher the values are for relatively rough surface and the lower for smooth surface. Here we can see types of lining and Manning's value. Manning's value is denoted by small n. So cement concrete lining is 0.013 to 0.022, brick lining 0.014 to 0.017, asphalt lining 0.013 to 0.016, wood panel clean 0.011 to 0.013, concrete line excavated rock 0.017 to 0.027. Next, this is our assignment for lecture number 23. The question is, how is the capacity of an irrigation channel decided for Indian irrigation conditions? I repeat, the question is, how is the capacity of an irrigation channel is decided for Indian irrigation conditions? So the last date of submission is already given here. And now we'll go through a video. At the same time, you can give your attendance in the chat box. That's all for this lecture. Thank you.